For the last example in this section, example 6, we are going to use summation notation to write each series. Okay, so we have two series that we're going to look at. Okay, they're written out and we're going to try to write them more compactly using summation notation, meaning the sigma stuff. Okay, so let me show you how to do this. Okay, so basically we know that we are adding stuff up in part A. Okay, so that indicates that we are dealing with a series. Okay, so we are going to need our summation notation. Okay, we're going to have to pick an index. You can use I, J, or K, whichever letter you'd like to use. Okay, I'm just going to keep it simple and stick with I. Okay, we're going to have to start somewhere and then we're going to have to stop somewhere, but we will get to that. Let's focus on trying to write down the expression that determines each term in the sequence. Okay, so what you need to do, my advice to you, is to look for patterns. Look for patterns. Whoops, I cannot spell. I don't even know what word that was. So look for patterns, things that are the same, things that are the different, or look for patterns, things that are the same, and things that are different. Okay, so let me move this so I have more room. Okay, so I've got my summation notation and I've got an index, but I haven't figured out where it's going to start yet. Okay, again, we're working on the expression that determines each term. Okay, what I'm going to do, okay, the terms are the pieces separated by the addition symbols. Each term has a 5 in the numerator. Okay, that is something that's constant. It's not changing from term to term. So in our term, every term is going to have a 5 in the numerator. Okay, in the denominator, there's always 1 plus, 1 plus, 1 plus, 1 plus. Okay, so that's another constant. Okay, so we're going to write that down. That's never going to change from term to term. What does change is what's being added in the denominator. Okay, first we're adding 1, then we're adding 2, then we're adding 3, all the way up to 15. Okay, that is going to be our I value. Okay, because remember, I is going to take on different values. Okay, so if this is going to be our I, okay, well, I is going to start at 1, and then it's going to go to 2, then it's going to go to 3, and it's going to go all the way up to 15. Okay, that tells us we need to start our I value at 1 and then go up to 15, and we're done. This is it. This is the answer. Okay, we worked backwards here. Okay, we were given the series. Okay, it was written out, pretty much term by term, and we had to write it compactly using the sigma notation. Okay, it's a great idea to check yourself once you come up with the sigma notation. Try, plugging in. Start with I equals the lower limit of summation. Start plugging and chugging in, I values, and see if you get the series that you started with. Okay, so that's how you do this one. Again, look for a pattern, look for the things that are the same, look for things that are different. Okay, that's my best advice. Okay, let's try one more. Okay, in part B, the series is 1 minus 1/4 plus 1/9 minus 1/16 plus dot 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 minus 1 over 400. Okay, this one's going to definitely be a little more difficult. Okay, one thing to notice is that the signs alternate. We have seen that happen in an example in this section, so keep that in mind. The signs need to alternate. We have to account for that. Something else you should notice is that every term seems to be a fraction except the first term. So we're looking for consistency. When we write down our expression, we need to pick out things that are the same. So what I'm going to do is I'm going to make this first term a fraction. I'm going to make it 1 over 1. Okay, so now I'm just making that simple little change, and that can help me, get started here. Okay, all right, so let's look at this. Okay, well, so far, I know I'm going to need summation notation. I've got to pick an index. Don't know where to start it. Don't know where to end it yet. But what seems to be consistent? Well, we're working with fractions. Every term is going to be a fraction. And each term has 1 in the numerator. Okay? So I'm going to go ahead and solidify that. We've got 1 in the numerator. Okay, now the denominator. Okay, the denominator is different. That's what's changing. Everybody's got a different denominator. We have to tie the denominator to the index of summation. Okay, we have to relate it to the I value. Okay, so remember, when you look at this first term, this is going to be I equals 1. The second term, that's going to be I equals 2. Then I equals 3, I equals 4, and then so on. Okay, you have to tie what's changing to the I value. Okay, here is how they are related. Okay, the bottom is I squared. Okay, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Okay, and then this last piece, okay, the denominator is going to be 20 squared. Okay, 20 squared is 400. So that tells you you're adding the first 20 terms. Okay, these are the types of things you're going to have to look for. This is the kind of thinking you're going to have to do. Okay, the denominator has to be based on the index of summation. It is the I value squared. Okay, as soon as you see that, you realize you're starting with I equals 1. Okay, that gives you the 1 squared in the bottom. And your last term has 400 in the denominator. That's 20 squared. So that means we're adding all the way up to 20. Okay, here is the answer. Okay, right here. This is how you write this particular series in summation notation. Okay, again, once you come up with something, start writing out the individual terms and make sure it adds up to what you started with. Okay, and I just realized I was about to stop the video, but I realized I forgot to account for the alternating signs. Okay, so let's talk about that and then we'll be done. Okay, so I think we saw alternating signs on page 1 very early in the discussion of this section. Okay, it was actually example 1B. Okay, and we had this sequence, and when we started writing out terms, we saw that the signs alternated. And it was because of this yellow piece. I even highlighted and said, hey, this is what's causing the alternating signs. Okay, so what I'm going to do is steal this -1 raised to the n plus 1 power and see if it works. Okay, it might take some tweaking, but this is a great starting place. Okay, so out to the side, I'm going to multiply this. Let me just go ahead and erase this. Okay, so we know the expression is 1 over I squared. Whoops. So let's see here. And I'm going to write out to the side because you're going to be multiplying by it. It's going to be -1 to the n plus 1 power. Okay, we're hoping this gives us the alternating signs that we need. Okay, again, like I warned you, you might have to tweak it. We're going to check it by generating terms. Okay, let's start with I equals 1. This would give us -1 to the 1 plus 1 times 1 over 1 squared. Okay, I'm plugging in 1 for I. Okay, This is going to give us negative 1 squared, which is going to be positive 1 times 1. So the first term is going to indeed be positive 1. Okay, let's check the second term and then we should be good. Okay, the second term, plug in, whoops, everybody should be yelling at me. Okay, this should not be an N. Okay, this should be an I. Okay, I am making mistakes. I am human, but these are likely the same mistakes that you're going to be making. When you turn a series into sigma notation, whatever your index of summation is, that's the only variable you can use in your expression. So when I had an I and an N, that's wrong. Everything needs to be either I or everything needs to be N. Okay, so I make the same mistakes that students make when doing something like this. It's very tedious. Okay, so let me start this again with I equals 2. Okay, plug in 2 for I. Okay, that's going to give us negative 1 to the third power. That's going to give us negative 1 times 1 over 4. Okay, so we're going to get negative 1/4 as the second term in the sequence. Okay, so the signs do appear to be alternating in the correct order. Okay, we're doing positive to negative to positive to negative. Okay, if we needed to alternate in the other direction, like negative, first comes negative, then comes positive, you might want to get rid of the +1 on the exponent, okay, and just do negative 1 to the I power. Okay, so here's your final answer. I know it got kind of congested there. You're summing up from I equals 1 to 20 the following expression: negative 1 raised to the I plus 1 power times 1 over I squared.